Hey everybody, how you doing? Good morning or afternoon or evening or whatever time it is, wherever you're from. If somebody can let me know in chat that you can see me and hear me, then that will be excellent. Any one of the chats, YouTube, Twitch, or Beam would be great. And then we'll get started. We'll get started doing as much as we can do today. But yeah, let me know. And Wook Up, don't worry about it at all. It's not a big deal that you weren't able to be here for last week. I'm glad you're here this week, and doing OpenCV has been pretty neat regardless. So it's yeah, it's been neat. So let me know if you can hear me in chat. Let me know if you can see me. Everything looks good on my end, looking at OBS, but that's not always the case. So if you can let me know, that would be excellent. Hey, Blue Gaming TV, how are you doing? Welcome back. Hey, Tobias, welcome to the stream from the UK. There's Posnifer. Someday I'm going to learn how to say that one, or I'm just going to call you Pause and be done with it, because that's the way to do it. Aiden can see and hear me. Okay, awesome. Blue Gaming TV asks, what is OpenCV? Can somebody explain? So, OpenCV is actually pretty cool. If you've ever played with Google Hangouts, used to have a thing, I think it still does, where you could put like a hat on someone's head, or I don't know, a clown nose or something on them. And Snapchat has filters that do things. I guess now it's Snap, not Snapchat. But anyway, has filters where you can put like a dog face on somebody, or on yourself rather, or whatever. So those are done with OpenCV. OpenCV is a library that will it will process images. So it'll look at a picture, and you can use that to then do things with that picture. So for instance, if you look at like feature detection here, let's see, let's look at like this corner detection. So there's a whole bunch of info here, but the idea would be that you can process this image and you can find out where things intersect, where they have a corner. And so then you could use that corner to find shapes, right? So like in this image here, if you can find all the corners of this cube, then you could figure out the shape of that cube by, well, finding all the corners, right? So OpenCV will let you do things like that. OpenCV will also let you do some other cool stuff, like, you know, you can use... yeah, here we go. Here's an image. So we have this shot of from a video camera, and we can do this background subtraction where basically it finds the things that don't move. Whatever things move get subtracted, right? And the things that don't move get left in. So then we could do this background subtraction, and we could either highlight just the front stuff, the stuff that moved, or we could have just the background, the stuff that doesn't move. So OpenCV lets us do a lot of stuff. Now, OpenCV is written in C or C++. I'm not certain which. I think it's C++, actually. And it has Python bindings. So that means that there is a Python library called OpenCV, or usually it's CV2, I think, is the library you import. And you can use CV2 to to use OpenCV's capabilities inside Python. So that's what we've been playing with. That's what we were playing with last week. Now I have to say, last week didn't go spectacularly well. We were able to do a couple of cool things. Like let's see. I'll show. The first thing that we did last week was we made this security camera. There it is. And so what this is doing is this is capturing live video from my second camera here. It's coloring it gray. It is doing a Gaussian blur on it with a custom like width and height and everything. And then it's flipping the image horizontally so that when I move to the left or to the right, my image on the screen moves to the right or to the left. So I made it into a mirror, effectively. We were joking that this is a really horrible security camera. So that's why I named it security camera. Okay, so so we did that one, and then we also did one that was based on a tutorial that does face and eye detection. So this is a live shot from the camera right now. And so it is detecting my eyes and my face. It's a little weird. Occasionally you'll get things like, you can see it detects my mouth as being an eye, which my mouth is not an eye. I'm not some horrible video game monster. So it does have some buggy bits and pieces, but for the most part, it does pretty well. It's not terrible. And also occasionally it picks up the testing goat back there as being a face, which is kind of fun. So where we left off last week was trying to do, let's see if this one will run. Yeah, so we were trying to composite the image of these glasses over my actual face, and we weren't having any luck with that. So we can keep playing with that. I'm going to leave this up to chat. We can keep playing with that, or we can try and just find some other tutorial and try to work through it. And then I want to play with something that's related to OpenCV but isn't OpenCV, and that's like image classification. So if we look, I do believe Microsoft released one. Microsoft image classification. Okay, yeah, there we go. I have to be able to spell classification. Yeah, where I know there's one that you can use. Is it this one? OpenCV playing cards to do card tricks would be awesome. Sorry, reading chat. So yeah, Microsoft has this image classification thing. Somebody has one. Let's just look for free image classification API. Yeah, okay. So we'll look through that. So image classification is kind of cool. You've probably seen stuff like this on I think Photos does this on Apple, on iOS devices. Google Photos tries to do this on like Android devices. And it's the idea that I can upload a picture that I took of a cat, and the software digs through it and goes, oh, that's a cat. And so then I can search for cat, and I get pictures of cats, right? So that's kind of cool. I'd like to play around with that if we have some time. But we'll find out. We'll see what we can do. So yeah, so over here in Beam, Posnifer has said that Beam has lower latency, which it does. It's typically better for live streams. Now I'm not doing what do they call it? FTL is their super fast one. I'm not broadcasting on FTL, so it won't be the lowest latency, but it's still usually a lower latency than YouTube and Twitch. Maybe we'll try and do the FTL streams another week, because that'd be fun to play with. And Paz has suggested doing OpenCV and playing cards, and I got a thing to talk to you about on playing cards, because I got an idea there. Blue Gaming TV has asked me, what do I want for Christmas? I don't really have anything in mind that I really want for Christmas. Just time? Can you give time? Is time a thing? Yeah, so we'll find out what happens on Christmas. So yeah, so let's see. One thing that we got the glasses pretty close. One of the things that we didn't get was the masking to work correctly on those glasses. Right? If you remember, when we run this, we still have the black background here, and we shouldn't have the black background. So we need to try and get rid of that at some point. But that's not super important. The first thing I want to do is I want to find the, I need to find the edges better. Sorry, chat, something came in. Wookup asks, OpenCV has bindings for Java and other languages too, so why do all live filter companies like Snapchat and others use CV with Python? I also like Python, but want to know why they choose Python binding. Most likely it's because they're using Python somewhere else in their stack, and they wanted to just stick with that. You're not... Once you're at the point of compiled software, once you're at the point of bytecode, right? there's really not a difference between Python and Java and C and whatever else, right? Because bytecode's bytecode, right? So because of that, we can do some cool things like we can transpile and stuff like that. But it also means that we don't really have to worry too much about speed once we're at the point of having the compiled code and we're just running the compiled code. We're not compiling anymore. That's where Python slows down, is the compile time of Python is slow compared to the compile time of like Java or C, because you have to translate from Python to C to bytecode, right? So, yeah, most likely they were already using Python somewhere else in their stack and they wanted to just stick with it. Or the person who built that feature at Snapchat only knew Python, and so that's what they built it in, which is fine. That's totally what I do. So, go for it, right? Okay, so we were grabbing these faces. So we've got the faces, and our min x is the left side of the face. And then inside here, we're getting which one of these is smaller. And then we're getting which one of those is wider. So is that what we want? Do we want that max x? You know what? Let's do the... let's find the code here for this rectangle. Here we go. And let's draw the rectangle at our stuff. So ROI. Let's look this up because I forget how this works. cv2.rectangle. So we have to draw on the image. Okay. So in that case, we want to draw this on face. Face is our image, right? Yeah. All right, so let's run that. Yeah, and so that's just doing those, just like it should be. I'll see you later, Tobias and Blue Gaming TV. Nice to have you around. So, yeah, thanks for coming by. Let's not do this part. Nah. All right, hold on a second. I'm going to change a setting here. Is the command / one not? No? Key map, okay. Comment. Comment with line comment. Command /. Yeah, that's what I'm doing. Oh no. That disappeared. Okay, so what I'm looking for is this one and these right here. Actually, this one can go too. I'm gonna do there we go. Okay. So let's try hold on here. Why is this line failing? Line 34. S greater than or equal to 0 in function set size. Oh, yeah. Because at that point we've got 0 and we've got y. Ah, okay. So here let's do face.shape. Or no, let's do x plus w. And this one would be y plus h. Where did we get this face.shape? This should be min x equals x, right? Y'all tell me if I'm doing something really weird here. Hey, look at that. They're kind of sort of where I wanted them to be. Okay, great. So that worked. Now let's see if we get rid of this. I don't think that will break anything, but let's find out. I mean, that sort of kind of broke something, right? That's not exactly what I want. Okay, so I'm going to take this part out. And yeah, I think we're good. I think we're good without that. Let's run that one more time. Yeah, I mean, that's sort of kind of right. Hold on, let me put that back in real quick. Yeah, that's much wronger. Okay. So we'll take this part out. Okay. So, what are we doing? Let's look at what we're doing here. So, we've got the face, and we've got the x, the y, the width, and the height of the face. So that's the box around the face, right? Because we're doing this face cascade. So then we're finding this eye cascade. Are we ever using eyes? No, we're not really using eyes. Okay, that's fine. That's fine. Okay. So what we really want is we really just want the top of the eyes, right? We don't actually need the entire eyes. Okay. And the glass's height isn't going to be right. Yeah, the glass's height isn't going to be the full height of the eye. It's going to be max y minus min y. Okay. Let's try redoing this one real quick. So it's just min y. Okay. So it can't do that. So what I want is I want to get the correct height for the width of the glasses. So to find the height to width ratio of that, I have to divide the height by the width, right? Glasses. Okay. Okay, right here, let's print out glasses.shape. And that will give us the shape of the glasses. Okay, so we don't care about that image. So it's 257 tall. What is my... There we go. So let's just look at Match shapes. That's not what I'm looking for. What do I have here? That's an image. Okay, so I am read. So I am read reads all of this stuff. And it gives me back, loads an image from the file and returns it. The image cannot be read. Okay. So file names flags. Print type glasses. So what I want to do is I want to get the okay, so that's NumPy, which I don't have installed. Let's install the NumPy docset real quick. There we go. So that is an ND array, which is a multi-dimensional array. So ND array. Okay, so this is an array, represents a multi-dimensional homogeneous array of fixed-sized items. So a shape is a tuple of ints. And what does that shape look like? Shape. Okay, and then we can resize that shape, which that makes sense. So, but it's going to be the width and the height. No, it's the height and the width. It's backwards. Okay. So my width is 749 and my height is 257, which makes sense, right? So if I'm just doing simple math, 749 divided, or no, 257 divided by 749, then it's a third of the size. So if I resized, okay. So what I want is I want glasses ratio equals glasses.shape 0 divided by glasses.shape 1. And the width, that's the width I actually want. Let's bring all of this up here. Okay. So the width is correct. The height is going to be equal to glasses width times glasses ratio. Will that make a more normal looking? No. Okay. So let's call round on this. And see, this is where you all figure out that I'm not that great at math. Okay. So, oh, no, wait. This isn't where I round it. This is where I round it. Okay, and so then the problem is that we have this thing where we're trying to get is min y max y. So what we need to do is we need to do min y which is that. So this is going to be min y plus glasses height. Right? Hey, check that out. Okay, so it's not perfect. But notice that our glasses now look, you know, correct, right? Like our glasses are the right size. Yeah? They're not squashed or weird or anything. And we still have our rectangle of our entire face shape. Okay. So now let's figure out how to get the glasses down to where the eyes are. I'm so excited. We're getting this to work. All right. Cool. So so the okay. So our min y needs to change. So let's try this. So for I in eyes, we want, or sorry, the max y. So we want the max y to be the how do we want to do this? We need to move down to the top of the highest eye. Yeah, we need to move to the top of the highest eye. So we can't do this min y equals y. That doesn't make any sense, right? Because that's at the top of the head. So we need to move down, but then whatever's the highest. Okay, so let's just do this. So we'll just say min y equals eyes 0, 1. Right? Yeah. Okay, so now for I in eyes, if I 1, or no, not even that, we'll just say min y equals max between min y, the existing min y, and I 1. Okay, so now that should change our stuff here. Yeah. Okay, so let's try running that. Tuple index out of range. Okay, let's print out y's and see what, or eyes. Eyes is empty at that point. Really? Well, that would make sense because we're doing y to y. This should be y to y plus h. Why was I doing y to y? Okay. So there's that. That didn't come out with what I wanted, but index error. Min y equals... actually, we can just pass because nothing's going to happen there. Okay. So print eyes, because I want to see what's there. So we've got that. Let's print min y. Okay, so min y, we've got 434. And so I said to take the first one, which would be this one, and to take the 1th value, which would be this one, right? Because the I is over 187 and it's down 275. And it's 245 square. So let's get to the end of here, and let's print min y again. Welcome to debugging. 275. Okay, so that worked as far as giving me the new location. So why that should have changed min y. Okay. Did I ever reset min y in here? No. So this rectangle draws this face at min y. Let's just make sure min y hasn't changed. It should still be 270 something. 275. Okay. Is it that we need... Oh, I know what we need. At least I think I know what we need. So, okay. So what I want to do is I want to make a copy of this one. So I'm going to say face y equals y. And then here at the end of this, min y equals face y plus min y. I think this is what I want. We'll find out. Hey, check that out. Those are more or less in the right place. All right, y'all. We're getting close. Let's turn off this rectangle because I don't want to mess with that anymore. I don't need the rectangle. And now let's see if we can get the mask part to work. So it's been a little bit since I played with this, so you're gonna have to forgive me on this one. Is that what I wanted? That is not what I wanted, no. Okay. How did we do that? So we had the glasses mask. The gray glasses, that's our glasses mask. And we're resizing that to the proper size. And then we're converting that to a gray image. Okay, as it should be. And then we're getting this ret to... And... Okay, we're getting this ret to and this mask by doing a threshold on the gray glasses. Should this be? No. Right on the note. Yeah. Yeah, pause. That was basically exactly where it was supposed to be. That was pretty cool. What if I make this a bitwise not? I don't think that'll work, but let's find out. Hey, that's not it. Okay. What if I do that with the mask inverted? That's not it either. Okay. I don't know what I'm doing here. Let's try XOR. What the heck? Let's just try all of these. That's not it. That's not it. Okay. Let's put this back. Okay. So then we're making this inverted mask, right? And the inverted mask is the opposite of our mask, which is what makes it inverted. So where did I get that mask thing last time? Do any of you remember where I got that part? That was computational photography? No. Camera calibration? No. Image processing. Is that it? No. But there might be some fun stuff in there to play with. Core operations. No. Arithmetic operations on images. We'll look at that one. Basic operations. Maybe that one. GUI features. Getting started with images. Maybe it was that one. Okay. So let's look at some of these. Image. That was it. This was it. Bitwise. Okay. So they open up the background image. Cool. We've done that. They open up the logo, which that's cool. We did that. So for us, this image 2 is our regular sized glasses, right? Okay. So then they produce this threshold on that. What if, can I just do, how do I use an image as the mask without making the threshold from the mask? Or do I have to make the threshold? What if I just did here, this is gray glasses? That did not work. That did not work. That did not work. Okay, so yeah, it seems like it should be this mask inverse, right? Let's try doing this just on glasses, and let's just see what happens. No, that did not work. Okay, it doesn't like doing that. It doesn't like doing that either. Okay, what is it unhappy about? It's this types and same sizes thing. Okay. Okay, let's see here. What do we got? So, okay. So they get the rows, columns, and channels from their image 2. So that's from that thing. So there's that. So then they get the shape that they want to do on their background image by getting the rows and columns of the mask. So we've got that right here. The ROI is the region of influence. It's the area that we want to do something to, right? So we kind of want 2 of those. We kind of want, let's do glasses ROI equals glasses. I mean, it's the whole thing, right? Can I do that? I bet I can't. So we'll do 0 rows and we'll do 0 calls. Okay. So then they convert image 2 into gray. So here's reading, this would be image 2 for them. Here's resizing it to the right size. That's what we want to do. To the glasses height and glasses width. We want that done correctly. And then they convert it to gray. We convert it to gray. They convert it to gray. And then they do this threshold on it. Right? So they get this ret, whatever that is, which I don't think I have ret anywhere else, so I could just call that ret instead of ret2, but whatever. And what is that, actually? Let's look that one up. So if I look at cv2.threshold, so that returns retval. Returns the computed threshold value. Kind of want to see what that is. Let's print that out real quick. $10. Huh. Okay. Just curious. Just wondering. Okay, so then they do this mask inverse where they do a bitwise not on their mask, which is cool. Okay, so then they're blacking out the area of the logo in the original ROI. So image1 BG is this bitwise and of ROI, ROI, and the mask. So if we were to do blacked out glasses, cv2.bitwise and of glasses ROI, mask equals mask INV. So then take only region of logo from logo image. So then they're getting just the part of the glasses. Okay. So then just glasses equals cv2.bitwise and of, for us that would be glasses, mask equals mask. Okay. So then they add the two together. So dst equals cv2.add, and they add blacked out glasses and just glasses. Okay. And then we would take this line and we'd say that the face, all of that is equal to dst. And let's make sure we're not doing anything else. We're not. Okay, and then we just show the face. No! Did not work. Okay. But we got the glasses in the right spot. Okay, we just had to figure out how to do... We just got to figure out how to do the thing. Oh, this feels like it should be not on that one. But that makes it pink. Okay, what if this is mask inverted? Can I do cv2.imshow? I keep typing img show. Imshow glasses. Just glasses. Can I do that? Did we get... We got 2. Okay. So that is definitely just the glasses. Let's open up Pixelmator. This is what we were doing all of our image editing in last time. Yeah, and so that was our original glasses. We don't need that one open anymore. This was what we put in, right? So it has this white background. So this one is definitely getting a non-white background. Okay, so it looks like that's working, or it feels like that's working. Let's look at something else on this threshold. What's this? Threshold value. Let's see what happens if we change this. It's a little clearer. Those are all coming out about the same, I guess. Okay. So let's not worry about that. Oh, wait, what if we go the other way? What if that goes up to 50? About the same. Okay, whatever. So let's leave that at 10. Okay. So blacked out. Let's show the blacked out glasses. Let's see what that looks like. That should be inverted. That should be inverted. That's a little closer. Project mobile app that can put live filter on face and cross-platform maps. I'm using JS platform for my app, so I have to code once. I don't know. How do y'all feel? Are we getting closer? Or am I just feeling like we are and we're actually not? Because if we're not getting any closer, we'll move on to something else. Hey, that didn't work. Okay. Okay, what was the bitwise and source 1, source 2? So what if it was like... No, okay. All right, so I think we're at about... I got one last idea. So let's try this. Let's go back to Pixelmator. Let's take these glasses. Layer, image, color adjustments, invert, export, JPEG, next. I take that back. I got two last ideas. So here, that would have been glasses mask. Okay, so let's try this. Still no good. Still no good. Okay. What if... I didn't do it. Okay. Okay, so here's my other idea. Is we... select all of that. But we come to this layer. We make a new image out of this. No background layer. Export as a ping. And let's say glasses ping. Transparent. Okay. So let me come over here. And this one, instead of that, we do glasses transparent .png. And then what I want to do here is I just want to do glasses. I don't know if this is going to work or not, but let's just find out. Nope, didn't work. Okay, that's cool. I'm just going to undo this stuff. And let's move on to playing with something else. But first, I'm going to look at chat because I see questions in here. So, Wookup says, one last question. I'm working right now on Project Mobo app that can put live filter on face and it's cross-platform app. So I'm using JS platform for my app, so I have to code once. And it will run on all mobile platform, but in OpenCV site, there is a separate section of how to make OpenCV app on Android. And how to on ISO, but my app is made up of web technology, i.e. HTML, CSS, JavaScript, and different JavaScript libraries. So my question is how to use OpenCV with JS or how to combine Python CV code with my JS app. A simple app built with web technologies that can access device camera, but how to code CV logic in it how. So look up, your best bets there are going to be either whatever, is there an OpenCV? It'd have to be Node. So there's Node.js bindings for OpenCV. So you could do something like that. So you'd still be inside JavaScript, but you wouldn't be on the browser website of it. You'd be on the, thank you. You'd be on the backend side of it. You'd be on the Node side. That, or you basically make an API. So your API would send like a JavaScript call off to a Python or Ruby or Java or whatever API that was somewhere. You'd send the image to that. That would do the processing, the OpenCV stuff, and it would send the image back. I don't know which of those would be better. It's probably going to depend on what you're more comfortable with. I don't know. Yeah, it's not an easy question to answer, and it's not one that I have nearly enough knowledge or experience about to be able to answer. So, yeah, my guess would probably be to start with an API versus doing it in Node, but I don't know. Maybe Node's pretty good at that. I don't know. Sorry. Pause says that they feel like we're not getting any closer. Yeah, that's kind of where I'm at. So I think we're gonna try something else. We're gonna play with something else. We'll keep it with OpenCV as much as we can, though. And then Ankit Verma asks, how can I get a job related to HTML, CSS, JavaScript online without any degree? That's a good question. And it's not always the easiest question to answer. A big part of it is, as Mutta says, is to get good and apply. You want to practice. You want to do as much HTML, CSS, JavaScript as you possibly can. You want to build a nice portfolio site. You want to go and build as many things for other people as you possibly can. That's going to be your best bet, right? Is to go and just start digging into how to do all these bits and pieces. But that said, a lot of it's just about getting yourself out there, right? Learn HTML, learn CSS, learn JavaScript, especially learn more modern JavaScript stuff. Angular and React are really, really in demand right now. They're not a bad thing to learn. And then typically you want to learn some sort of CMS as well, like especially how to work with that CMS. So like you'd learn WordPress or Drupal or I don't know any others. Sorry. And you want to learn how to work with them, how to work with their templating engine, stuff like that. And then you can start to market yourself as like, oh, well, if you have a WordPress site, I can build themes for you, and I can make your site look just like you want it to, and you can still get the benefit of using WordPress. So that's kind of one of the bigger ideas and one of the bigger ways to play with that kind of stuff and to start getting jobs there. But a lot of it is just practice and applications. Like, just try getting your name out there as much as you can. Ekx says the issue with the glasses just proves it's a good idea to switch to contact lenses. Not gonna happen for me. While I appreciate the joke, and yes, this will be a lot easier with contact lenses. I had some eye damage due to wearing contact lenses back when I was a teenager, so not doing that ever again. No. Okay, so let's look at, I don't think it's probably not going to work to do the image classification thing this week. We don't have a ton of time. But let's look at last Friday. I had this link open. And this is about automating the card game 24 and using Python and OpenCV to solve this, right? So it would look for these cards and figure out what was going on. So I've got, there's a game that we all really enjoy playing at the Treehouse office, and it's called, there's my camera over there, it's called Hanabi. So if you haven't ever seen Hanabi, Hanabi is a pretty awesome game. And Hanabi is neat because it is a co-op game. It's completely co-op. We all play together on the same team. But, I'm going to switch over here so I can see my camera to make sure that I'm showing you all this stuff correctly. In Hanabi, you would have a hand of cards. So I'll assume that we're playing with 4 or 5 players. So I would have a hand of 4 cards. Let me get these up closer here so you can see them. There we go. So they have numbers and they have colors on them, right? I've got like 2 green ones. I've got 2 3s, a 2, and a 4, right? So the problem is you can't see your own cards, right? So I have to hold my cards like this. So all I see is the back. Wow, dropping cards. All I see is the back of my cards. I don't see the front of my cards. So the problem with that is I don't know what I have, right? So you, as the other players on the team, have to tell me what I have. So we'll say Paz is sitting over to the side, and he's looking at my hand, and he's like, hey, we really need to get out that red 2 that's right there. So he would spend one of the available hints, and he would tell me that it was red or that it was a 2. He can only tell me number or color, and you have to be complete. So, for instance, I have 2 3s in my hand. So if he says, or if they say, that's a 3, they actually have to say these are both 3s. And then I don't know which one's which, I just know they're both 3s, right? Or I have 2 white cards in my hand, right there. So if you were trying to point out the whites, you would have to say these are white. You couldn't just say this one's white or this one's white. So you can see the challenge there, right? I don't know what cards I have. So what would be cool, and we've been talking about this actually at Treehouse for a long time, is building an API for playing Hanabi. So it knows how to play the game, and everybody who is playing, anybody who wants to could make an app to play the game. So that would be really cool. One of the things that I think would be neat is if you had a way to play Hanabi with your computer without having to have another player, but you could play with actual real, like, physical cards somehow. I don't know how you'd do it, and you probably wouldn't, but let's see if we can teach the computer at all, because I really doubt we can, but let's see if we can teach it at all to identify a hand of cards. All right? So that's my challenge for right now. Someone has just popped in. I'm sorry, I can't read Cyrillic, so I have no idea how to say your name. If you want to post an idea for how to say your name, I will happily try to say it. But they said, "Hi, I'm from Russia. Started learning on Treehouse about 2 months ago, and now I'm working in a small digital agency as junior front-end developer, creating my first websites. I want to say thanks to all teachers of Treehouse." Well, that is amazing. We are always happy to find out that people have used our lessons to actually, like, learn and get themselves jobs, get themselves into the industry. That's amazing. Congratulations. That's awesome. I'd love to see some of your stuff if you want to share some links later on. And I will be sure and pass your thanks along. Okay, sorry. So let's see if we can, in any way, shape, or form, identify a card or two. All right. So let's start a new file, and let's call this hanabi.py. By the way, if you're looking for a good Christmas gift or Hanukkah, a winter holiday gift for somebody, the Hanabi game is usually about $10, and it is absolutely amazing. So I think y'all will really enjoy it. I know I do. So let's see how we can do this. Okay, so first of all, let's do import numpy as np. That seems to be a given. And let's do import CV2. Right? That's what we've been doing. Let's get up here. Yeah, CV2. Okay, cool. So, sounds like I have more to do R&D on. Probably would get it and also share it with you. God, please help me. and hi, Kavi Arasu. Nice to have you back. So, let's just see what we can do here. And I'm going to do this live on camera because I'm not. Let's open up Photo Booth. And yeah, there we go. Okay. And I'm just going to get a picture of one card, and I'll do a fairly high value one, or high contrast. So we'll do this, and we'll get a shot. All right. Cool. So now let's take this image and let's export that over here to, and let's call this card.jpg. All right. So now we've got card.jpg. So there's our card. Hi, Sanif. How are you doing? Glad to have you on the stream. So IAM equals cv2.imread, and we're going to say this is card.jpg. Gray is cv2.convertColor of IAM to cv2.color_bgr to gray. I still think that's weird that it's blue, green, red, and not red, green, blue. Blur is cv2.Gaussian blur. We're going to do that on gray with a 1:1 blur to 1,000. And then let's do flag and thresh. cv2.threshold blur 120, 255. cv2.thresh binary. All right, so now, I'm not sure what all we have here right now. I got a pretty good idea of what's going on. Let's go over this real quick. So right here, we're reading in the image. Nothing really new there. And then here, we're converting the image to gray. Also nothing new. Here, we're blurring the image. This 1:1 blur should be a pretty small amount of blur. And let's double check what this Gaussian blur does. So K size is the kernel size, is the width and the height, so that's how big each of the little Gaussian things is. And then sigma x, sorry, is the standard deviation in the x direction. Okay, so we're setting that as being 1,000. And then what we're doing here is we are doing a threshold on the whole thing. So now let's get these contours and hierarchy. All right, yeah, there we go. cv2.find contours, and we're gonna do that on thresh. cv2.retter tree. Not sure what that one is. We'll have to look that up in a second. cv2.chain approx simple. And then contours equals sorted. Hey, sorted, how are you doing? Contours key is going to be equal to cv2.contour area. Reverse equals true. And num cards, which where did we get num cards from? Why aren't you showing us all the code, dude? All right, so I got some questions. Let's see what's up over here. So Senif asks, can you also explain where is Python used and its applications? So you mean just in general? Python's kind of used everywhere. Python is a very, very multi-purpose and general-purpose language. Typically, if you hear someone describe a language as general-purpose, it means there's not any one niche that the language works best in, right? So, like, JavaScript up until Node came out was a browser language, right? It really only worked in browsers. Node kind of puts it to where it can work a little bit of everywhere, but it was very, very much predicated on being used in browsers. Objective-C was a multi-purpose language. You could use it for a lot of different things, but it was mainly used for building applications for Mac or iOS, right? Same for like Swift. Multi-purpose, general-purpose languages are really languages that you can kind of use for anything. So, for example, YouTube was originally built in Python. Reddit is built in Python. NASA uses Python for all sorts of stuff, for simulations, for prediction software, for, launching satellites or whatever, and for building just websites that they need. So Python's kind of just used a little bit of everywhere. You won't find it a ton on mobile. You won't find it a ton as desktop applications. That's typically because it's a little bit trickier to get it to compile to work on those platforms as, just programs all by themselves. But that's fine. That's, something we can figure out later on. Yeah. Sorry. Okay. So let's go back to looking at this thing, and I want to figure out where they got this num cards from. So they're just passing in num cards. So I'm just going to set this to be a 1 because we only have one card. Right? So now for each card we need to register each card into a rectangular representation. To do this, we identify the rectangular representation of each card. This is done by approximating a polynomial from the contour, which is simply a vector of points, and then finding the minimum rotation-free bounding box. Let's just print out some of what we've got here, and let's just see what we can find. All right? So let's print contours and just see what's there. Too many values to unpack. Does find contours send us something new? Find contours. What does that return? I really wish these docs were better. These docs are not amazing. It returns the image, the contours, and the hierarchy. So let's just do like IMG here. Okay, so we're getting a bunch of contours of a bunch of different things. So that's cool. I mean, the benefit that is in this image is that it's they're on this black background, which I sadly don't have. Let's look on Google image search for Hanabi, and see what we can find. Maybe we can find just an individual card, all on its own. We have the predictable amounts of anime. Okay, let's just try searching for Hanabi card. There we go. Sweet. The cards are sadly all stacked on top of each other. Can I find one where they're not stacked up? I could make one of these not be stacked up. That would work. Oh, there we go. That's cool. Those are basically all on their own. View image. Save that image to downloads. Let's open up Pixelmator again. And let's bring in this image. So let's open up downloads. That's not it. Hanabi, there we go. All right. And then I'm going to crop this down to be just these two right here. And then we will save that. To our public. No, not public. CV live stream, that's it. And I'll call this cards. Alright, and then I saw a couple more questions come in, so I will talk to those real quick. Okay, let's see what we've got over here. Sergey says Python's really awesome, and it is, thank you. I'm glad other people on the stream really enjoy Python. And Paz mentions it's exciting to learn and realize that you can really do anything you want with it. And a lot of scientists are using Python to do their research and graphing. Yeah, people use Python for research and graphing a lot. If you look at the libraries NumPy, SciPy, and Pandas, those are pretty much the most used scientific computing packages there are, especially along with the rest of the Anaconda stuff. So those are all amazing. And Paz also mentions that Beware is taking a crack at making Python code run anywhere. That's sort of true. It's not exactly making Python run everywhere. It's using Python to make software that runs everywhere. So Beware does, it's kind of sort of transpiling. But basically, you write your code in Python, and then Beware's tools will take your Python bytecode and make it work as, say, Java bytecode. And then they'll use that Java bytecode to then create whatever Android widgets you need so that your software will work on Android. So it's pretty cool. I hope that Beware is not quite to the point yet where I could demo it easily in a live stream, but I hope that in a few months it will be there, and I will definitely do a Beware live stream. I might do one anyway, just to mess with it. Grumpy Chicken asks, what other languages do scientists use? They use Python a lot, they use Perl a lot, they use R a lot, and SQL. That's about it. SQL. Yeah. There's a lot of CSVs that get used, or TSVs even, tab separated values. Yeah. A lot of languages, but be careful looking at scientist written code. It's often very scary looking. And Sergey says, use PyCharm. Remember a long time ago, he told us that Vim or Emacs is the best tools for him. You know what? Vim and Emacs are great. I love both of them. I've been having issues with Vim lately and haven't had time or energy enough to fix them. So PyCharm is a little bit simpler in that respect. But yeah, I don't really have a favorite editor. I love Vim keys. I want Vim keyboard bindings. Other than that, I don't really care what the editor is. So yeah, I'm just kind of using whatever I got. And I don't think there's any such thing as a best text editor. I really don't. I think text editors are, one and the same. Okay. So that's cool. I want to see, what can we do? Can we show the image? cv2.im show. Card. Let's see what img looks like. No? Okay. No? Okay. Let's come over here and let's do this. And that's in a while true. We don't want the while true there, though. We want the while true just out here. That's all fine. Let's take off this while true. Okay, yeah, so that's just our normal card image. And then if I try to show img, there we go. So that looks like that kind of gives us the contours, kind of gives us the shape of the cards. But that's not really giving us, like, I don't see any way that I could pull the ones out of there. So let's look a bit more at, this might be a good place to look through. Let's look a bit more at what is going on here. So, bounded, identifying and registering cards. Okay. So let's try doing a thing up here, and we'll say num cards is equal to 2. For I in range num cards, card equals contours I, parry equals cv2.arc, length card true, approx equals cv2.approx poly dp, on the card 0.02 times parry and true. Rect is cv2.min area rect, contours 2. That seems like a magic number there, but okay. R equals cv2.cv.box points rect. Okay, so that's the minimum free rotation. Okay, that's the bounding box. Okay. So then H is np.array 0, 0, 4490, 0, 449, which I'm not sure where the 449 came from, but okay. np.float32, transform equals cv2.get, perspective transform, approx and H, warp equals cv2.warp, perspective, im transform 450 by 450. So I wonder what that does. Yeah, see, I was wondering about that. This contours thing here. Let's do that as like -1. Box points. Okay, so we can take that out and we lowercase that one. So there's something going wrong here. What's going on here? Assertion failed. If that's equal to 4 and that's equal to 4. Okay. So, you know, in case it's not apparent, I don't know what I'm doing here. But let's move the while true up here. Let's indent that. Let's put that there. Yeah. So something it doesn't like here. Okay. So there's H. That makes sense for H. I think. But it wants there to be 4 of those? Oh, and there is. Okay, there's 0, 0, 4, 4, 9, 0, 4, 4, 9, 4, 4, 9, and then that. I'm also not sure where those 4, 4, 9s are coming from. All right, so this isn't going very far. So let's try something else. Let's play with some more OpenCV stuff, and let's just see what we can find that's interesting. Or if any of you have ideas, let me know, and we can definitely try doing some other stuff, playing with some more things. Because, you know, there's all sorts of stuff to try out. Let's check out this contours one. Okay, contours can be explained simply as a curve joining all the continuous points, having the same color or intensity. Okay. So let's try this out. Let's ditch all of that. Oh no, all of our code's gone. And then let's just try let's figure out this contours thing. All right? Let's work together. Let's understand contours, and then maybe we'll figure out other things as we go on. So we can have our gray cv2 dot convert color. I am cv2 dot color bg to gray. All right, and then return value and thresh. There we go. cv2 dot threshold, and we're gonna do this with gray, not Gary, gray. And then, so that's our threshold, our maximum value, and our type. Okay. Contours hierarchy dot find contours. Thresh cv2 dot retter tree cv2 dot chain approx symbol. Okay. And if I remember correctly, there was an image thing that came out of there that we didn't care about. Can you try to make a game that helps you practice typing? That way I can print out little stickers for my keyboard and get better at the Dvorak keyboard layout. Maybe? I don't think we can do that today, but that's definitely something that we can look at in the future as an idea. I will let you know, though, that whenever I switched over to Dvorak years ago, what I did was I actually just went to here, to DVZine, and they have what was it that I was looking at? That was it. They have this image here that I printed out and taped up on the wall next to my computer, and I just looked at that while I was typing. And it took me 2 weeks, maybe, to get pretty proficient at it. I mean, after a day or two, I could type it, like without having to look at the keyboard all the time, like this keyboard. But yeah, it was like maybe 2 weeks, and I didn't need the little taped up thing anymore. Now, see, I'm a little weird because I type Dvorak, but I leave my keyboards as QWERTY. So, like, if you see my keyboard, it's QWERTY. I don't change the keys around. So this is amazing because people come and try to type on my computer, and they have no idea what the letters are doing. It makes no sense at all. So yeah, like I suggest just learning to touch type it, which is obviously that's what you're wanting to do. But yeah, so try that, I guess. I don't know. Okay, so let's print out Len contours. 642. That's a lot of contours. Let's download this image. That goes off to a file. Yeah, okay. So let's save linked file to downloads. And then let's take this linked file and stick it in here. Yep, that's fine. And let's change this over to test.jpg. And 1. Sweet. We got 1 contour because there's only 1 continuous outline all the way around. Right? And then if we were to print contours 0, or sorry, let's print the length of that. Then we've got 244 points going around the contour. Okay, so the contour is the contiguous shape all the way around the boundary, the area that has a similar color or intensity. Which means that looking at these Hanabi cards probably wouldn't work super well because you can see, like, while I could find the 3 or maybe the symbol below the 3, I would have a hard time distinguishing the entire card, right? So that might be a much harder thing, and we have to deal with the fact that, like, trying to find a non-white one. There we go. We have to deal with the fact that we have both the number in a color, and we have the firework in the middle, and we have the building, not shadow, where the light from the firework is on the building at the bottom, that are all in that same color. So it might be a hard thing to pull out the contour of. So it's something that we would definitely have to test the threshold on, I would think. So what I actually want to do, let's call this one, that's fine that it's IM. Let's do a new IM here. IM read of cards.jpg. And I want to see what this threshold image looks like. So I'm going to go back to here. I'm going to grab this. Go back to here. Paste that in. And get rid of all that. And I want to show thresh. Because I think thresh is the thresholded image. Maybe it's ret. Yeah, so see, like, that would be really... That would be really, really hard to pick anything out of. Let's see if we can change this a little bit. Oh, that didn't do any better. What if I make this like 255? Oh, that didn't work either. What about like 200? Ah, that's a little better. See, now we're starting to get just the ones. Okay, so let's try... Can I make this one higher? I bet I can't. Oh, I can. Okay. Which means I could change this to like 300? No, I can't. 255. Yeah, so that doesn't work. Oops. That doesn't work. Okay. Dion Bowles asks how to install OpenCV on a Mac. It was not easy. OpenCV on a Mac, especially with Python 3, is weird to install. I think the way that I did it was through Miniconda. Miniconda. If I remember correctly, I installed Miniconda through Homebrew, and then, or not through Homebrew, through PyEnv, and then I used Miniconda to install OpenCV. If you search for OpenCV 3 macOS Miniconda, you will find a tutorial on how to do that, where they will give you all the information you need for how to actually do the thing. Alright, so let's try 225. This probably should just stay at 255. Yeah, that's pretty good. What's that one there on the end? So threshold type. Okay, so we can do thresh binary, binary inverse, truncated, threshold to 0. Let's try that truncate. Thresh trunk. cv2.thresh trunk. That didn't work. Of course, that may be a thing where I need to change, like, this value. Yeah, that's not working. Okay. Thresh to 0. We're getting some interesting results there. Yeah. Okay. So this might be a thing to play with and just see like what else we can get. Let's try this triangle and just see what that gives us. Then we're gonna move on. I'll move on to something else, because I realized just watching me play around with images popping up isn't necessarily the most exciting thing ever. Okay, so that was like that. That was a 0. And we were using that one. Alright. But that wasn't 127 or 128, that was 127. Does that really matter? That one point can't matter. Okay. So what if here we did IMG? And if we show IMG, I think we tested this before. No? That was different. Okay. I also wonder about this chaining thing here. Anyway, I'm going to stop being distracted by this. Okay, so let's look at the next thing here. So now we can draw the contours. Okay, so let's try that. So maybe we can do that here. cv2.draw contours on IM with these contours. -1 is the contour index. So I guess the last contour. And then 0, 255, 0, and 3. Oh, image is not defined. That's right, it's not. Sweet, check that out. We've got the contours outlined in a green. So that's kind of neat. Or we can fill the contours. So let's do that one. cb2.draw contours, im contours -1, 0, 255, 0, -1. Do that. And then now we've filled it with the green instead of outlining it in the green. Okay, so that's kind of cool. That's kind of neat. So I'm guessing the 3 would be, well, let's look this up. Draw contours. So we did the color and then we did the thickness. If it is negative thickness, the contour interiors are drawn. Okay, cool. So then we can also do line connectivity. Hierarchy is if we only want to color some of the contours, if we only want to draw some of them. Max level contour. Okay. So let's look at line here. Line type, 8 connected, 4 connected. Okay. Let's not worry about that just yet. That can wait. But that's kind of neat. So we can outline them or we can fill in the inside of them. Okay. So that's nice. So the third argument to draw contours, so 1, 2, 3, this -1, which is, if we go look back at draw contours, that's the contour index. So that's which contour to draw. And if it's negative, all the contours are drawn. So the third one can let you only draw some of the contours. Okay. So that's kind of neat. So let's try a new thing here. cb2.draw contours im. CNT, which was contours 0. 0, 255, 0, 0, -1. And what does that do? Oh yeah, that's correct. That's not. That doesn't look like it did anything. Like I don't see anything drawn there. I think I missed a thing. There we go. So that filled in the fourth contour. Okay. Okay, that's a little weird. I'm not going to worry about that one for right now. Does that work? That doesn't work because there's only one shape in there. But if I took test JPEG, let's test this out. Let's play with this. I realize that we're not building something today, per se, but we're definitely getting a good chance to try out some different things. And I think that's good. I think that's important to just mess with stuff and just see what you get. So CV live stream, and I want to open up test JPEG. And I want to change the canvas size percent. I want to make it 200% wide. There we go. And then I want to take this shape, move it all the way over here, and then duplicate it, move it all the way over there. And then export that. And I'm going to call this one test 2 because it's got 2 things in it. So that makes it test 2. Okay, so now let's bring in test 2. Yeah, check that out. So that's cool. So I did contours 1. Where did that go? There it is. Contours 1. So now, let's see if we change this over to contours 0. Oh yeah, we don't need cap.release. Alright, so it must be finding them from the 0, or from the right to the left. So that's cool. So then, if I was to do this as just contours, okay, one color's that one. So what I could do is I could do something like this and do, oops. Sweet. So now one's green and one's blue. So that's kind of neat. All right. That's a cool idea. So we're able to kind of find all the shapes in something, and then based on finding those shapes, then fill something else in, draw something else. All right. So that's cool. That's neat. Okay, I like that idea. I think that's a neat idea. Okay, so now we get to talk about masks. And we've already played with masks a little bit, right? We did the whole thing with the glasses that did not work. But it's fine. It's fine. It's fine. It'll work. Okay, so we're going to save that linked file. And we're going to grab that one and stick that into CV Livestream. Okay, so now we're going to do this new bit here. So we're going to play with these masks. Okay, so let's not worry about... So let's actually do this. Let's take this file, Hanabi, and let's rename it. And I'm going to name this one to contours. Okay. And then I'm going to bet I want to leave those things alone. Oh, sorry. I want to duplicate this. I can't duplicate. Oh, copy. There we go. So let's call this one masks. And this is the file we want to work on. Alright, and then let's take all of these and get rid of them. And so right now, if we run this, we just see that image, which is not the image that we want. We want... What was the name of that image that we downloaded? Balls. Alright. Oh, it's a ping. And we did that, and then it opens up our frame. Okay, cool. So there is our frame. All right, great. So now, let's come down here, and let's say for H, and, oh, wait, we need to bring back, let's bring back a bunch of this stuff. All right. So we're going to change this to be balls.ping. We're going to leave the rest of that stuff alone, but I'm going to get rid of these draw contours, all right? So we have our contours, we have all that stuff. So for H and CNT in enumerate contours. So if you remember how enumerate works, we get back an index, and then we get back the item at that value, or at that index. Mask is going to be np.zeros for gray.shape. np.uint8. So np.zeros, the little tiny bit of NumPy that I know of, what's that doing is that gives us an array filled with zeros that will be the size and shape of, in this case, gray.shape. So it'll have the same number of columns and rows as gray.shape. And if we remember, gray.shape is an array that is the height and the width of the image that we're looking at. Wow, we've learned a lot. Even though it doesn't necessarily feel like we've learned a lot, we've learned a lot. So we're going to do draw contours on the mask that we just created. And then CNT, which let's come up here. CNT equals contours 0. All right. Let's double check that. Yeah, contours 0. Okay, cool. So we're going to do that. CNT and then 0, 255, -1. Mean is equal to CV2.mean. I am mask equals mask. That doesn't do anything. And it doesn't do anything because I misspelled zeros. Who woulda thunk? How weird that I'm not getting... Let's do, where's that security camera? No, not security camera, demo. That's what I want. And then over here, I want to do cv2.IamShow, mask, and I am. I think that's right. And then I want to paste that in. And then this. That's fine, whatever. Mean? That didn't work. That's a tiny little window. There has to be something here that I'm missing. Do I want to show mask? There we go. Okay, so there's our first mask. There's our second mask. Alright. So the contours only found 2 contours. Did you just hear a baby? You did. You heard my 4-year-old running past the door, talking about something. I don't know. It snowed here yesterday, or the day before, yeah, rather. So all the kids are home from school yesterday and today. So yeah. All right, so we're about 10 to 12. This is where I normally stop messing with stuff. So I think I'm going to stop messing with stuff. It's kind of cool, though, that we were able to get each of the things to show up. That was kind of neat. I was happy to be able to get that to work. So, yeah. Let's... Let me answer questions if you have any questions. So everybody feel free to ask questions, and we will we'll wrap up the stream. What questions do y'all have for me this week that you haven't asked already? And also, give me some ideas for next week. I think next week I want to do something different. I want to do something non-OpenCV. Maybe we'll look at building the typing game like Paz was mentioning. I don't have the first clue what I would do to make that game, but we can definitely give it a try and see if we can find something. But I have no idea, so we'll find out. But yeah, let me know what questions you've got, and then we will wrap up the stream, and I will see you all next week. What is next week? Next week is right before Christmas. Oh. Will we do a Christmas stream? Maybe we will. Maybe we'll just draw random. We'll just do random stuff for Christmas. We'll find out. We'll do an advent calendar all in one day. So yeah, let me know what questions you have about anything. You know, it can be Python. It can be literally anything. Oh, sorry, I got a question here on Twitter, which is odd. But Matt's good too asks, what programming language was my first and what others do I know? So, first is maybe a little hard to answer. When I was in very early elementary school, my school had a computer program, and on Apple IIe's, they taught us Logo and a little bit of Basic. If y'all remember Logo and Basic, they were amazing, fun languages. In fact, if you enjoyed Logo, check out the Turtle module in Python. It's maybe my favorite little module for Python ever, because it's so amazing. But after that, the first programming language I learned was probably JavaScript. I learned HTML, CSS, and JavaScript when I was in high school, and I did that for a long time. I picked up ActionScript and just ActionScript for both Director and for Flash when I was in college. That was kind of horrible, but I learned it. I taught myself PHP while I was in college. I learned Ruby and other stuff after college. I taught myself Python. And so Python's my favorite. Out of all the languages that I know, I've done a lot of PHP, I've done a lot of Python. I can read and understand a decent amount of what Ruby's doing. I can usually figure out what Java is doing. C and C++ I'm really, really bad at. Lately I've been looking at Rust and Racket, which are both pretty neat little programming languages. Racket's really neat because it's very functional, like functional programming oriented, which I really like. So I think that's pretty cool. So I don't know a ton of languages, but I know a few. I know enough to get by. So Paz says that they have a snowstorm on the way in Boulder. That's fun. I've got a friend that lives in Boulder. So I'll have to ask him how the snowstorm is going. He does a lot of really cool JavaScript stuff there. So if you ever get a chance to meet Brandon Conkle, do meet him. He's a pretty cool dude. And you also said that Scrapey was getting interesting when we did the stream on web scraping. Yeah, Scrapey was getting neat. Maybe we'll do more Scrapey next week. Maybe we'll work on Scrapey. I've got I have a Twitter bot that I created a while back, which is based on it uses Markov chains to generate Against Me lyrics. Against Me is a band that I really like. So I took all their songs, put it into a text file, read that with a Markov chain generator, and then generate lyrics from it. I've been wanting to do the same thing for Tom Waits and Modest Mouse. So maybe we'll try and create a scraper spider that will help me create the lyrics files needed for those bots. So maybe we'll try and do that next week. That sounds like a good idea, actually. And then Kavi says it's 1 a.m. in India and they're feeling a little sleepy. By all means, get some sleep. Go to bed. There's no reason to lose sleep over watching my streams. I'm glad that you're here. I'm very happy to have you, but trust me, sleep is... Oh, I wish I had more of it all the time. And it's my own fault. I just don't go to bed. So anyway, any other questions before I call it a day and I start fighting with Windows again? Anybody else? Last call. You got about 5 minutes. Let's assume that next week we're going to do more Scrapey. That we're going to use Scrapey to go and grab lyrics off of lyrics websites, put them into a text file for me so that I have all the lyrics, just the lyrics that I want, just the important bits. We'll strip out all the extraneous stuff and stuff like that. Kavi asks, do you develop features for DuckDuckGo? I don't do anything for DuckDuckGo with the exception of I have made a few bang commands for DuckDuckGo. So DuckDuckGo has this pretty awesome feature called bangs. So you can do an exclamation mark and then like A for Amazon or YT for YouTube, and then it will search that site for you. So I've added a couple of these for like, I think I added the one for Django REST Framework, and I think I added one for somewhere else, maybe for Treehouse. Do we have one for Treehouse? We don't have one for Treehouse. Huh. So, sorry. Yeah. I haven't developed anything for DuckDuckGo themselves. I don't work for DuckDuckGo. I work for Treehouse, but I have added bangs to DuckDuckGo because I find bangs to be amazingly useful. So yeah. So Dark Dev says, I can't see the point in learning so many programming languages. I make games in Unity using C#. If you want to switch game engine, it's not that hard to switch from one to another programming language. Yeah, I mean, learning multiple programming languages has pluses and minuses, right? The more of them you know, the easier it is to get confused. If you ever want a really good example of that, talk to my coworker Craig, who teaches Java. Craig used to write Python a whole lot. He now writes a lot of Java, and he writes a lot of JavaScript because he and Chalkers do a lot of JavaScript together. And so Craig constantly has to kind of like switch languages in his mind. Like, he'll start writing something and then be like, oh, wait, no, I can't write it that way in JavaScript because that's not how JavaScript works. I have to write it this way. So there's that as a downside, right? But on the upside, typically the more languages you know, the less you think in a particular programming language, right? You start to think in design patterns, you start to think in approaches more than you think in particular languages. And that often really helps to make sure that your programming is more... Your programming often comes to be better designed at that point, simply because you realize approaching a problem doesn't depend on the language. Approaching the problem depends on what the problem is. So there's a lot of bonuses to knowing more than one language. I don't suggest anybody ever learn only one language. I suggest learning at least two, and ideally two that are somewhat different from each other, right? Like if you're going to learn Python, go and learn C#, go and learn Java, go and learn something that's a little bit more strict and strongly focused. And that way you'll approach Python differently, and you'll approach that other language differently too. And usually that's going to make you to be a better programmer just all around. It's kind of like, as an American, I have the problem of I only know one language. I only speak English. I would probably be a little bit better off in the way that I think about language, the way I think about communication, if I knew more languages. So at some point I should go and, learn French or German or Japanese or something, just because it will help me in how I approach communicating with other people and how I approach just saying things. But like spoken languages, the more programming languages you know, the better you are at picking up new ones. Like, once you've learned your second or third programming language, it's really not that hard to pick up a fourth or a fifth one. So, I don't know. It's fun to play around with languages, too. Like, so I just got a new Android phone. First time I've ever had an Android phone. And, so my plan for early next year is I'm going to take the Android content at Treehouse, and then we're going to do some live streams of me trying to build Android things. I don't know Java. I don't know Android. But we're going to try and build some Android stuff on live streams. So we'll find out. It'll be fun, right? It'll be great. Okay. So it's 12 o'clock. I'm going to call quits on the stream. I'm going to end the stream, but I'll still be in chat. So if you want to send any more chat messages on the YouTube chat, feel free. I'm still hanging out there. I'm just not going to have the video stream on anymore. Thank you all so much for being here. Be sure and check out Treehouse for learning JavaScript, Python, Ruby, PHP, C#, all sorts of different languages. And yeah, I hope you all have a wonderful week, a wonderful weekend, and I will see you next Friday. So goodbye, all. I'll talk to you later.